Good afternoon, everybody. I'm Michelle Munson. I'm CEO of Aspera, and I have the pleasure this year at Virtual NAB to introduce a new platform that fits with these themes of size and speed that we've been talking about today. So this platform is called ASPERA Files, and it's a SaaS offering that's really designed to solve the problems of sharing media at scale. It brings together both the convenience of utilizing cloud-based storage and on-premise storage with Aspera transfer capability and its speed and power at distance, along with the ability to brand and customize your own organization's experience on a platform that's hosted and run by us, which is quite new in our media world. So what I want to do today is introduce the Files platform in terms of its purpose and where it fits in a world that's full of file sharing services, and explain the core problems that it addresses that really have not been tackled before, its features and benefits, what you can do with it, and then I want to talk a little bit more about the core capabilities and how you can experience it firsthand and sign up, and some of the core technologies that underpin it. So with that in mind, just to get started, the core proposition of Files is that we have a situation now where everybody needs to share media from where it's originally created to others in the world, where there should be no impediments to that. Should be able to start and finish where you like, which might include taking advantage of cloud storage. May also include on-premise storage, and it ought to be something that's purely distance and media size independent. So what that means is several things. First of all, it needs to accommodate massive sizes. And by massive sizes, I mean single file sizes that can be gigabytes and terabytes, and also large numbers of files, digital film reels, etc. The challenges, as we see with existing file sharing services, are that they work very well for documents. In fact, I see Dropbox is one of the sponsors. But as you get into media-sized assets, for many reasons, Dropbox and their competitors are really not positioned as an architecture or technology to accommodate the weightiness, if you will, of the sharing of media of that size. Second issue is speed. And we just had a great presentation on the need for speed and storage. Along with that is access, or sharing, or transfer. The media supply chains now, especially with OTT, have multitudes of bytes of media that need to flow around the globe, not only in days or hours, but sometimes in minutes. Also, of course, the storage environment is diverse, and people want to take advantage of the economics of cloud-based storage, as well as keeping media on-premise where it makes sense. In addition to that, there's lots of demand for self-service, where the storage could be consumed at will in hosted platforms. And then, of course, the last point is security. Right? The value of the assets is paramount, and in a way it's the currency of the industry. So it's more than simply encrypting the data as it moves on the wire. It's ensuring that the access control is intentional and precise and able to be audited, in addition to enforced across the diversity of platform and sizes of media. Now, underpinning Aspera Files and its capabilities, of course, is the Aspera FASP technology. And this is the key innovative platform that our company has built out over the last 11 years that allows for several key properties that are distinct from classical transport with TCP. And this is going to be really important in understanding the differences in the capabilities of files as compared to traditional file sharing services. At the top of the list is the fact that FASP in its efficiency is independent of network distance. That's kind of a mouthful. What it means is that transfer times do not degrade with longer network distances. If you think about that, that creates a massive degree of freedom for building an architecture that can move large media at distance, at line speed. And if you think about then today's networks, which not only are in the tens to hundreds of megabits, but get up into the tens of gigabits per second, you're talking about being able to move gigabytes in seconds. not just minutes. The second point is the predictability. So because of the efficiency of FAST, the transfer speeds don't degrade. What that means in an architecture like files is irrespective of where the infrastructure is or where the files start and finish, given bandwidth, the transfer times are utterly predictable. And that, of course, opens up the possibility of having long-distance infrastructure, combining together on-premise and cloud, and doing it in a way that can serve the media supply chain. And then the scale. So FAST does not also have any dependence on the scale or size of bytes transferred. And what's important about that, of course, in this case is you might be sending large numbers of individual files and directories. You might be synchronizing single large files. In those cases, the performance remains the same. So what that then brings us to are the key points that create the need, right, and the opening for this platform, in spite of the fact that there are many commoditized file sharing services. We know today, and most of you probably use, document-based file sharing services that are hosted on cloud environments. OneDrive from Microsoft, Google Drive from Google, Dropbox, Box, WeTransfer, and many other sort of second-tier competitors. The problems specifically in each of these existing solutions really boil down to the key differences with ASPERA files. Number one, the ability to deal with anything large. In all of these existing platforms, it's not possible to have unlimited file sizes or numbers of files going in and out of the platform. There are storage limits, practical transfer size limits, and speed limits. All of these are built on traditional TCP-based transport in addition to using their own storage platforms. That also means that if you're not close to their infrastructure, you're limited in how fast the stuff can go. So if you're producing a film on site, or you're working in some type of original programming context in OTT, you're a cable or a VOD company that's trying to distribute, right? In any of these environments, impractical. Even if you're supporting a sales team that's trying to take rich media assets or advertising, right, or game previews out to share with advertisers. All of those downloads are limited by the fact that each of these platforms has their own fixed storage built on TCP transport and file size and number limits. Then in terms of security and access control, it's commonplace to offer some type of encryption, and some of these services offer encryption of data at rest in their environments. The problem, though, becomes that you're always forced to get your content into their environment. You do not have the option as a media company to take what you might have as a vault of storage that's secured on your network behind your firewalls with the kind of access control you've chosen and connect it into this environment or their file sharing environments. That is not true with files. You have complete ability to do that. And then we get into what you can do with these platforms. Each of the platforms has some strengths and weaknesses in terms of being able to share or sync or send something, right? And again, because of the architectural limitations of having to use their storage, for example, right, and also the difficulties in distance, you're constantly plagued with the limitations of the sharing paradigms that they offer. And lastly is audit, compliance, and control. You may be able to see all the access control that goes on, who logs in, who touches what in their environment, but what about your content that might be on-premise? Also, what if you decide you want to take advantage of a third-party cloud, like Amazon, or like Google, or like Azure, or all the myriad of others that are going to grow and scale to give you economy of scale over the next few years? That simply isn't possible. All you can do is put your files and your content in the place that they host them. So this brings me to the key points of the files architecture that differ from these traditional file sharing services in ways that are so important to media. Number one is obviously simplicity, right? But that simplicity combined with the power of a distance neutral and size neutral transport that's as fast as line speed in all cases, and the flexibility to have your content stored on-premise and any third-party cloud with any major object storage file system, because we support it directly with ASPERA direct-to-cloud capability in our software, and security that provides access control across all of these environments, as well as security and privacy of the content end-to-end and at rest. And let me explain a little bit now about the architecture. So Files itself, as a user experiences it, is an overlay SaaS service that's multi-tenant. Each organization gets a URL for its presence on Files. And Files itself comes with built-in servers and storage, those that we run and host. Those are an option for customers who just want to self-service, to get on and use this on a project basis without having to provide any infrastructure of their own. Then customers can also connect in their on-premise Aspera servers, and those are backed by any type of storage, as Paul talked about earlier, be it NAS or SAN, local drives, on-premise object storage. Our transport supports all of them these days. And also customers may choose to connect in Aspera server software on public clouds. And those public clouds that we support today include all of the majors, many of which are presenting here: Amazon, Azure, Google, SoftLayer, for example. Now, this kind of environment becomes very flexible to the end user because what they see is a browser interface that looks like their desktop for browsing, sending, and sharing file content. However, the underlying servers and storage are independent of the experience that they have in the overlay. And the components then include, of course, the web interface, which is how users experience file sharing and sending and transfer. Then the built-in transfer servers and storage for those who choose to use that. And then, of course, the existing hybrid Aspera infrastructure that might be on-premise or on third-party clouds. Let me talk a little bit then about the sharing concepts. So at the very top is the organization. Organization not only has a name and a URL, it's the presence on Files. And any media organization from very tiny to very large can sign up and establish an organization with us. Within that, an organization create as many workspaces as it likes. And those workspaces are a slice of the experience, which slices the users, their content, as well as the branding that goes along with that. And this is a very powerful concept because it means the same server software and storage may be securely shared across multiple project groups at will, easily set up, and the user scoped within that. Right? So you get a full multi-tenancy, if you will, for each project in your organization. Of course, files and folders are literally the bytes on disk, and our core software preserves all the structure and obviously the integrity of those files and folders with a native direct to storage transfer capability in FAST, so none of this is virtualized, very important for scale and speed and preservation of content. A package then becomes a collection of files and folders that can be sent as a group or received in through a Dropbox. And then loose files and folders can also be shared in place or made available for upload or download. And then perhaps most importantly, you can literally drag files from one folder to another in order to share them where the transfer might be going across the globe in the background. Underneath all this are transfer clusters of our software that we run and operate, or individual nodes or clusters that customers run and operate on-premise or on their own cloud environments. And just to give you a bit of an idea, today I don't obviously get to give you a live demo, but you can experience this yourself by signing up at files.asperasoft.com, and there you will see some of the interesting things that you can do directly with this. So a few of the key concepts. Number one, being able to send out a package to users or groups, or to invite third parties to send into you via a Dropbox. Sharing files and directories with other users in place where the access control allows you to control whether they can upload or download, and being able to expire those links on demand. Being able to move content directly between shares simply by dragging in the interface. Also, as an administrator, being able to add nodes, new servers, and storage at will, and also being able, within that, to see not only what's been done in a given workspace, but across the entire organization. And the activity logging is very fine-grained so that you can see at a per-user level who is logged in, who has shared what with whom, who has uploaded, who has downloaded packages, files, directories, etc. That's also searchable across the entire space. And for extra details, we collect metadata and also provide previews for the media itself. There is an API, finally, for those who are developers, and you can access that on developer.asperasoft.com. So getting into the offering models now, how can one take advantage of this and acquire it for your enterprise? Well, first of all, there are a couple of different models. The first is if you sign up and you have no Aspera software to bring to your files infrastructure, there is all-inclusive service provided, meaning you don't have to do anything. Your organization comes up, you have built-in servers and storage, and you simply subscribe to a plan. And the plans range from 100 gigabytes a month up to petabyte a month as our standard offerings. And those cover, that would be the transfer that you do in and out of the platform. There are built-in workspaces, and there are also built-in storage for keeping content stored while you're working. Second model allows you to extend the all-inclusive offering to include hybrid capabilities, and that means that you can connect in Aspera on-demand subscriptions running on third-party clouds, and you can also connect in your on-premise Aspera nodes. It's very easy to do this a la carte. You simply add those options to your files plans. This gives you a little more detail in terms of the offerings, and you can see that this is very practical at a starting point for a small organization. For example, the 100 gigabyte plan with at a personal level is $140 a month. Very appropriate for a tiny media company. And this also, of course, allows you to scale up to petabytes a month, as I mentioned, for large media organizations. This service has been live for Aspera since December, and out of our customer base so far, we have over 300 organizations on the platform, and of those that are purchased customers so far, they range the gamut from the smallest to the biggest. Underneath this is a special technology that we built a few years ago that's now used widely in media for delivery in and out of object storage platforms or transport. This is called Aspera Direct-to-Cloud Transfer Capability. And this is a ability in our software to move content in a single fast session so that it writes directly to or reads directly from object storage. The efficiencies of this are maximum, so there are no stop-offs. We're not writing the files 2 times. This is all done as a single transfer session, and the bandwidth control over the network and to the storage are all part of the dynamics of that session. This is extremely important technology because it lets us underpin the files capabilities across Amazon and Azure, the Swift storage on SoftLayer, Google storage, and also to extend to the new object storages coming from companies such as HDST and CleverSafe and others that offer private object storage in a native enterprise environment. Now, of course, this is also fully compatible with the Aspera server software working directly against the local file system for SAN or NAS. And just to wrap up, I wanted to share with you a little bit about how to get signed up. So Files, being a SaaS offering, allows you to discover it and sign up on the web. So all you need to do is browse to files.asperasoft.com and register your organization. That will automatically provision your organization's site. You get a confirmation back from us that gives you administrative login, and that brings up both your organization as well as the ability to establish 1 or more workspaces within it. We offer free evaluations that include some gigabytes and a month worth of capability at minimum on the platform, and it's a great way to try this out and get started. So this year at NAB, we invite you to visit with us, Aspera, in the South Hall, in the lower level, where we'll be showing files. And we also run a bi-weekly newsletter where we announce the new capabilities in the platform. So as soon as you sign up, you'll instantly be subscribed to that. And that'll allow you to learn about new features as we continue to introduce them. That concludes my talk today. Any questions?
So if I want to use this as we have petabytes worth of data.
Yep.
And I would like to use this in association with one of the clouds to provide backup.
Yep.
So do you do object-based backup, or I don't care, I give you the file,
Yes.
it's dispersed across the network.
Yep. Yeah, absolutely. So I don't know if how much you all got out of the direct to cloud storage transfer capability, but the whole point of that is to take file-based data and transfer that directly to object storage, whatever the amount of media might be, and petabytes are typical. Do that as transfer or do it as synchronization, where synchronization literally means a stateful update, and do it over IP network with the full use of the available bandwidth. And that capability is something people are already doing in files, where they set up a node, which a node is ASPERA server software against the cloud object storage. ASPERA On Demand is the name of this. Set that up as a node in the files instance for the org, and then have an on-premise node connected and simply drag between them for archiving, or set up an automatic job for syncing, for example.
Right, and if I didn't want to keep a local copy at all, but I wanted it archived in the cloud
And then delete it.
and backed up in the cloud.
Absolutely.
So it's dispersed and distributed wherever. So you will do that.
Right, so another configuration on this is to, after synchronizing, to automatically delete from the source. And then when you think about something like a Glacier and offline storage behind this, you can also configure, certainly on S3, you can configure the buckets to automatically age what might be transferred directly into Glacier, so it stays there and then is no longer also on S3. So this is a integrated capability with the software.
Great, thanks.
You bet, thanks.
Hi, Werner Gold from Red Hat. I have one question. Would the FAST protocol also work on top of a multicast environment?
IP multicast, I assume you mean?
Nothing specifically.
Okay. Well, so multicast is a term that gets used loosely and very specifically. IP multicast is a specific type of IP routing. I think many people in networking probably know that. Maybe if you're not a networking guru, you might not know that. So FAST as a protocol is a unicast-based protocol, meaning at the routing layer, the packets are routed in unicast style, not multicast style. Then multicast is sometimes used to mean a one-to-many kind of distribution. And in the looser sense of one-to-many distribution, our software products are used abundantly for one-to-many distribution. But at the IP routing layer, it's a unicast-based transmission. An interesting question is, will IP multicast ever see the light of day in the modern media industry? And this is a question that's been out there since I graduated from grad school, and now that's quite a number of years ago. And in truth, there aren't uses of IP multicast at scale in content distribution today over the core of the internet. There are some isolated uses in ISPs and places like that at the edge. So what I think is more interesting and what ASPERA focuses on is how to make one-to-many distribution easy, practical, and efficient without expecting to kind of re-engineer the internet fabric for multicast routing, which, just for a number of administrative and scaling reasons has never really taken off, right?
Did you want to ask?
So multi-unicast, there you go. Thanks for that. Another question.
Yeah, I still didn't really fully understand how you say you can guarantee performance across distance without any penalty. So
yes.
Maybe
how does that work? How's that work? Very, very, very fundamental question. So if you know our core technology well, bear with me, it will be very redundant to state this, but in essence, the FAST protocol is different from TCP in the way it regulates data rate over the network and accomplishes reliability. And the most important aspect of that is the fact that the effective data rate is not coupled to packet loss. Now, how does one do that? Well, I mean, there's no simple answer to that question, but the class of solution that it is a new way of doing separated reliability with retransmission where the rate of retransmission is not coupled to loss on the network. And the reason that then correlates with making the speed independent of distance is that packet loss and latency accrue with network distance. Fast reliability is independent of those two factors and its efficiency. So we can guarantee the same transfer rate over distance as we do over short network paths. And it's a new approach in the sense that all of the ways that we do reliable data transfer over TCP, such as HTTP, which is most common, follows a different approach. What's that? Right. Well, of course, there's always the propagation there's always the propagation delay of light, but the order of magnitude of latency that impacts and causes the bottleneck in TCP performance is several factors greater than the propagation latency of light. And what I mean by that is if you look at TCP performance, by the time you get to 100 milliseconds of latency, right? That's a wide area network situation. That's sufficient to have reduced the effective throughput just based on the TCP windowing to something that is well less than the practical bandwidth of most networks. And FASP, in contrast, over 100 milliseconds of latency has exactly the same speed as it does over 0.1 millisecond of latency to kind of put it into perspective. And that bottleneck, right, that exists with TCP-based transport is really the essential thing that's kind of driven the need for this new approach, especially as media files grew up over the last decade because people want to move them far. Right. Any other questions? Well, thank you so much.